Which actually brings me nicely, segues nicely, Tristan, thank you, into the next question, which is actually the complete opposite extreme of what we just spoke about, which is, does it limit what we can achieve and imagine? So AlphaZero, just for some context, was a product by Google that was trained to play a big Chinese game called Go and some other games as well.
It was a product by DeepMind before they were acquired.
Well, they're now Google DeepMind. Yeah. But the purpose of the tool, but the reason it was different was because it was not programmed as a rule-based system. It basically just played against itself until it got bored of playing itself. And by that point, it became the master of the game and beat everyone from that point on. However, they repurposed the concept and they applied it to medicine. And they trained basically against 60,000 molecules they had in the data set, and they looked and they found that by defining the problem, as you say, well, and working out, well, we don't want it to harm people, we want to use molecules we already know, etc. It actually learned relationships that implicitly in the structure of the data set that humans hadn't actually marked as relevant. And therefore, when it actually produced the output was kind of unexplainable, but it worked. Now, in a medical context, I see a colleague over there can probably comment further, but medical context, obviously that's great because it helps patients by exposing some risk, also mitigated. From a structures perspective, if we got proposed by an AI system a structure that was unexplainable, but the system was saying to us, you know what, this is 100 times better than what you're currently doing, it's going to save the environment, it's going to save your population, would we trust it or would we reject it because we don't understand and potentially lose out on the efficiencies that that system is giving us?
So if it couldn't provide enough evidence as to how it worked or why it worked, we'd reject it.
I agree.
I mean, ultimately, you do a test case and you would do smaller kind of examples and stuff to try and work out whether it does work. But that's just like scientific method, I guess.
Yeah,
prototype.
But it doesn't stop it coming up with all sorts of things you haven't thought of.
Potentially extrapolate.
And I guess that's what I was trying to say earlier. You know, you can explore opportunities, you know, using tool sets and using machine learning or however, so either a data-centered approach or a simulation approach, which you wouldn't have conceived of otherwise. So you're opening up, you know, the world of possibilities in a way that we can't do otherwise.
Yeah, I suppose it's looking at the world in a different way, isn't it? The same way that we can't imagine how a dog smells, we can't understand how an AI thinks, in a sense. Okay, is there any questions from the audience at this point? Because we're coming towards...
There is actually, sorry, there was just a little point. It happens to be a structural computational expert at ARA who's looking at, if you use machine learning to come up with structural propositions, you know, because they're effectively filling in gaps. So this is when you start with a load of simulations and then you use the data from your simulations, you use machine learning now to predict the results of other things that you haven't simulated. He's now working out a way where by taking away some of the factors, you can put a probability of error against those models as well. So there are ways being developed now where the black box can also effectively self-interrogate by using it in different ways, so you can get a degree of how accurate the mythical one might be, if that makes sense. So all these things are developing as well. You know, things that we see as real problematic at the moment. I don't know how it did it. I don't know whether I can trust it. New things then come along. And we were talking about this again earlier. You get to a point where only the AI can check the AI. Where are you then?
I've got one that I just wanted to, with a room of engineers, get out there as a kind of a slightly trippy theory that's been suggested. So I don't know if anyone's seen the video generation that OpenAI is doing, which is basically image generation, but obviously through time.
Is that Sora?
Sora, yes. And within that, obviously, it's temporal. So it's created. It understands how things move through space, how things react over time. You know, how someone moves, how objects interact, how, you know, like, and it's been trained just on videos, on just lots and lots of videos. But within what it's producing, it's simulating. Sorry, I shouldn't say simulating. It's creating realistic appearance of fabric moving, of water moving, of different, you know, say wind reaction. And essentially what's being theorized is that it's to be able to do that, it has some internal, it's kind of recreating its own world of physics. Like it's never been taught physics, but based on, so it's not, obviously it's simple, but you could see in a few steps down the line how that would be it could be used in a predictive manner where without any knowledge of structural engineering, it knows kind of sizing and it knows how things in these conditions normally would appear. And so almost without even touching the science, it could be useful in a manner of predictive way. But then obviously you would need to bring it back into whatever way you actually want to use it. But just as a
I think it's sort of
yeah, exactly. And that if you watch if you go away and watch some of the videos of the things that are happening in the video, and obviously just what you see isn't the full extent of what's going on, but yeah.
Yeah, we should definitely have a chat afterwards. We've done some similar things like that, and yes, they look like they're obeying physical laws. Again, it's actually about the interrogation. So when you actually begin to interrogate them, they're not. There's big inconsistencies there. But of course, it is that thing of you have to know what to look for to understand that it's still fake, basically.
Yeah.
There is.
But fake stuff, an approximation.
I think treating, sorry, just to say that obviously this is, I think, considered, a beta release of something has been advancing year on year. And if you look at where image generation was 2 years ago to where it is today, this could, even if you say 10 years time, it's the direct, everything is going up basically.
Yeah, I mean, just to add, I think what could be tremendously powerful is if you can actually put in, the underlying physics as well. Then there's some really interesting stuff that can go on.
Yeah, I was going to say, if you can ground that back to something constrained, that you can say, actually, it was relatively fine, but this wasn't. That's probably not the verification bits. But what I was going to say, you had a question.
Yeah, just a quick point. Obviously, there's AGI as well. So then you get kind of the judgment element into this, and obviously a lot of our job is based on judgment. So it's quite an interesting topic.
Yeah, to see where it goes.